Tutorial 1 for this idea. Determine the force component of superheated steam acting on the blade. The blade is stationary. The blade moves to the right at 100 meter per second. The blade moves to the left at 100 meter per second. So in this situation, we have a water jet here, for example. So and then this water jet, this fluid are moving at certain velocity, and then this fluid will hit a blade like this, and then the blade will deflect the movement of this fluid. So in this situation, if we push it same amount with the force generated by the water jet, so the blade will remain in stationary because the left and right forces is equal. But if the force here is weak, so means that the water jet will push the blade to the right. But if you push too hard, so maybe you could overcome the force that comes from the water jet here. So you may push the blade to the left at that moment. So means that according to this equation, we could calculate what is the force, the reaction force that acts in this system. So that the first idea that you should know. And then, okay, we go for question number 1. The blade is stationary. So means that we imagine that the blade is stationary, it's not moving. And the idea how to make sure that the blade is stopped is we need to supply an equal force from right to the left to hold the blade from being pushed by the water jet. So we need to draw the control volume. So it is simple. So this is the control volume because the water is being deflected into certain angle. So we draw the velocity, the real velocity is here. So and then this is the n direction. So this is the real velocity and this is the n direction. So and then every fluid has pressure. So in this situation, please bear in mind that we need to add a pressure here acting on the surface from outside to the control volume. So it will become P1A1 at this direction and also direction perpendicular to the surface here. So we could write P2A2. So and then we have we could understand that to force is vector. So means we need to solve solution problem for force depends on the direction of x and y. So to ease your calculation, so it is good for you to split the force and the velocity according to x and y direction. So for example, if we have a velocity v2 at this direction, so we could split it into y and x direction as this one, and this is the equation. So we have v2 sine theta for the vertical velocity and v2 cos theta for the horizontal velocity. So and then we have a force here, P2A2. So we could split it into horizontal, which is P2A2 cos theta, and also the vertical force. So you could write as P2A2 sine theta. And as I said in this diagram, okay, to make sure that the blade here is remain in static, it's not moving. So we need to hold the blade with same amount of the force that occur from the other direction. So we add that direction, or we add that external forces as Rx and Ry. So Rx here is the reaction force on x direction, and this is the reaction force on y direction. So it is okay for you to draw the Rx and Ry in this direction, because if if you get answer in negative, means the direction of this one is actually reverse. You need to reverse the direction to cancel the negative sign. That's all. So it is okay for you, not worry. Please do not worry about the direction of Rx and Ry, because you could fix it, you could change it at the end after you get your final answer. So, and then in certain textbook, they will write that the momentum equation can be written as total force is equal to the total rho V and A and V, because the V and A here is actually represent the flow rate. So here, total F, the sigma of F here is the total force that occur due to pressure and reaction force. So that in the control volume diagram, we need to add force due to the pressure and the reaction force that occur in the system. Force due to the pressure must act perpendicular to the control surface. Reaction force normally predicted as this one. So our final calculation could determine whether its direction correct or not. So again, do not worry about your reaction force, whether it is going to the left or going to the right, upward or downward. It is okay, because at the end, you will know whether your first predicted direction is correct or not. Okay, so we go back to answer this question. So please refer to this diagram for the following slide. Okay, so in some textbooks, they will write particularly about x and y direction. So maybe they could write as sigma of fx, it is equal to of the total sigma of rho Vn, A, and Vx. So here you need to understand that. So this is the total force in x direction. So rho V and A. So Vn here is the velocity according to n vector, but Vx here is the velocity according to x direction. So we go for the force. We go for the force first here. Okay, so here the sigma force means we need to add all forces due to the external force and pressure. So external force means sometimes it may be gravity. You know that when mass react with gravity, so you need to multiply them. So mg is weight, weight is force, so you need to count as external force, so you need to put into this one. And then when you have pressure, pressure will act on certain specific area, so it will create force, and then you need to calculate that force. And then also the reaction force that occur when you hit something. So we just assume that to the right is the positive direction. So we could write Rx is positive, P1A1 is positive, and P2A2 cos theta is positive. So you could refer to this one. You could see that the direction of this one is in positive. So this is in positive, and also this is also in positive direction. So and then this is the left hand side about the force. So and then we go for the sigma rho V and A and V. So what you need to do is you need to identify how many surface that you have in your system, because you need to identify, you need to analyze each surface in your system. So if you see the free body diagram that we have, we only have two surfaces. Means that this is the first surface as inlet, and this is the second surface at the outlet. So means that we only calculate two terms. So in the first term, so you just imagine we have rho V and A and V. So rho is constant. So Vn means you just looking back to this diagram, so the velocity v1 here, so it's move opposite direction with n, so we give them negative sign, negative v1. We have a1 and we have v1. So v1 here is the velocity according to x direction. So and then plus we add with what happened to the outlet surface here. So this here you could see that the velocity and the n direction is at the same direction. So means that, so we'll have rho, we have Vn is positive, we have A2, so we have A1 here. So and then here we need to calculate about the Vx. So Vx mean, okay, we need to take V2 cos theta as our Vx, and it moves to the left, so means that it is in negative sign. So we give this equation negative V2 cos theta. So this is negative V2 cos theta. So this is the very basic idea to solve or to substitute value in momentum equation. So please bear in mind that the value of V or Vx is not the same with the Vn. So Vn is the velocity according to the n vector. So and then if you solve this problem, you will get the Rx here is equal to negative 1200 Newton. So means that previously we assumed that Rx is moving to the right, but we get negative answer here. So and then to change negative sign into positive, what you need to do is you need to reverse the direction. So means now Rx is actually act from right to the left, and the magnitude of the force is 1206.528 Newton. Okay, you could calculate the same thing here for Ry, so you will get it 696 Newton. So for Ry here, it's very simple. So we got total force for y, it is equal to total momentum in y. So we have rho a Vn and Vy. So and then for Fy here, so it's quite interesting because we don't have P1 here, but we still have P2 sine theta and also Ry. So Ry is in positive. So we start the Ry negative minus with the P2A2 sine theta. So we have minus P2A2 sine theta. It is equal to, so and then at the inlet here, there is no component of y, so we could neglect the value, and then only this one, because we have a velocity move like this one. So it is moved in a positive direction. So we could write as according to this equation is rho a Vn is positive, and then it is equal to positive V2 sine theta. Okay, so in this situation, because this water jet is actually moving in atmospheric pressure, so the pressure here is PATM, so we assume that it is equal to 0. So in this calculation, okay, the P2A2 will give us 0 because the atmospheric pressure is equal to 0. That's why we could only have Rx in the x direction, and also we only have Ry in y direction, because there are no forces due to the pressure, because pressure is atmospheric pressure. So and then in this situation also you need to understand that the velocity that reach at this point is 400 meter per second. So and then normally we assume that the blade is very short. So it means that it could maintain the velocity on this surface. So means that we assume that the velocity at outlet here is also equal to 400 meter per second. So this is the common assumption in solve this problem. However, if question give you certain statement telling you about what happened on the surface, so you need to follow the question. So for example, question say that the resistance on this blade is 10%. So means that it will reduce the velocity. So means that maybe the inlet is 400 meter per second. So we need to deduct 10% according to the friction along its move on this turbine, on this blade. So at the outlet here, maybe it will become 360 meter per second, because 10% of the kinetic energy will be used to overcome the friction. So, but normally, we do not have that too detailed analysis for the momentum equation. B and C here, okay, now you need to understand that for B and C, we have two velocity. One is the velocity of this water jet, and the other one is the velocity of the blade. So what we need to do is we just use the idea of relative velocity. So means that if we have a velocity 400 meter per second here, and this blade is moved to the right with 100 meter per second, so means that because it's moving in the same direction, so the velocity relative is 300 meter per second. So you just do same equation as I showed you previously here. So but the velocity is not 400 meter per second. You just imagine that the velocity of the water jet is only 300 meter per second, and you could imagine that the blade is stationary. So again, same things happen to C when we have a 400 meter per second to the right, and then this blade will move 100 meter per second to the left here. So means that if we use the idea of relative velocity, so means that the relative velocity is now becomes 500 meter per second, while the blade is remain stationary. So you just substitute into the equation to solve this problem, means a problem of B and C here.